Hey friends, welcome to follow up. Let's have a look at problem 1721, swapping nodes in a linked list. This is a daily challenge problem. In this video, we are going to share two methods or two solution formats based on traversal. So both the two solution formats are one-pass solutions. So here we are given the height of a linked list and an integer key. So we are required to return the height of the linked list after swapping the values of the case node from the beginning and the case node from the end. So here the list is one indexed. So here are two examples because example 1 has a visualization. Let's focus on example 1. So here the length of this linked list is 5 and the key is 2. So the second one from the beginning, this is corresponding to the node with value 2, and the second one from the calling from the behind will be 4, right? So we are going to swap the values of node 2 and node 4. So the result is 1, 4, 3, 2, 5. So the return is the height of the linked list after modification. So this is example 1. So similarly, you can interpret the example 2. So here we want to swap the values of the fifth one from beginning and from the end. So the corresponding value is 7 and let's see, 10 minus this is 10 minus 5 plus 1, that is 6. So we're going to swap the value of 7 and 8. So here we have 8 and 7. The additional constraints or assumptions are the following. First, the number of nodes in the list is n, and n is larger or no less than k, and bounded above by 10 to the power 5. And node values are in the range 0 and 100, but both ends are inclusive. So with that said, we are ready to do the coding part. So here I'm going to share two solutions. So the first one is based on the observation that if the length is n, so if we are using one indexing, then the index for the case node from the beginning is k, and the case node from back has index n minus k plus 1. So it's important to notice the indexing. So in other words, the index sum of the two nodes involved is nothing but n minus 1, right? So with that said, we can first write some very direct over both code. For example, you can do one pass to get the length, and then do the second pass to get the case node from the beginning, and then you can do a third pass to get the case node from the back. Then you swap. So this way is not very economical, right? So here, for the digesting purpose, let me first write a one pass solution. But this solution, I'm going to treat space for speed. So in other words, the solution I'm going to first present will use a lot of space, right? But it will demonstrate the main logic, and then we improve. So here I'm going to use a dictionary, right? So the dictionary will store the index and the corresponding node. This way, once we finish traversal using one pass, then we can do the swap, right? So here let's write a utility function to make this logic clear. So we are going to have a height, right? And then what we are going to do, let's use a result. The result is a counting variable, count how many nodes are in the linked list, right? Then we set current to be height, and then current, then we are going to count the current node. So that is result incremented by 1, and then we also record this one. So this result also plays the role of indexing, right? So for example, if you current is height, this is the first index, so it's D1 equals height or current. And then we are going to set current equals current next, right? And then we are going to return result. So this function get length actually does two things. First, we can get the final length, that is the result, final state. And then in the process, we also stored the index and node, right? And then we can call this function. So let's see, we can call this get length, right? So after we call this function, so we are going to also populate the information to the dictionary, and then we can do the swap. So we need to swap the two nodes value corresponding to index k value and index n minus k plus 1 the value, right? So we just need to swap the values like this. Then dk value, right? This done the problem logic. So now we can do the return. We can do return, right? So this is the one solution format. So this solution is short, and the logic is also very simple. The drawback is that here we are using the dictionary to store the index and node information, so it actually uses a lot of space. So, but before we make improvement, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So this is about it for the first solution format. So now let's look at the second solution format. So for that, I just wrote some information here. Let's see. So basically, we want to argue that we don't need to find the length of n in order to do the job here. Here, let's use this list as an example and assume k equals 3, right? So what we want to swap value is actually a3 and a8, right? So this is the third element counting from the beginning, and this is the third element counting from the end, right? So the thing is that we can use two pointers. So we start a pointer a, so from a1, and then we move to a3 because we know the key. We can move to a3. So then a3 is one node involved in the swap, so we can record it. And then we start another pointer b, right? So at the very beginning, when we start the pointer b, a is at a3 and b is at a1, and then we move a and b simultaneously forward. So no matter how long the linked list is, as long as a arrives at the end of the linked list, then b will arrive at the correct position. In this example is a8, right? Then we record this b, and then we can switch the values corresponding to a and b. So this is just one path, right? We just need to use two pointers to record the corresponding nodes. Let me copy this solution class, and then let's code in here. I'm going to change this to be v1, right? So let's delete this part, and here we don't use a lot of space. So now let's first look at this coding part. We're going to separate into several stages. For example, first we can get the case node. So here notice that we are using one indexing, right? So as in listed here. So this is actually very routine. So first node, so let's first make it height, and then the count is 1. And then what we are going to do? Well, count is less than k, so we are going to move first node to the next, right? So first node equals first node next, and then we are going to increment the count by 1. So after we exit this while loop, count will be equal to k. In other words, the first node is nothing but the case node to be involved. So then we just need to keep the first node state, and then the next step is to get the n minus k plus 1th node. For this, actually, we can initialize the b here. Let's use b. That's last node equals head, and then we can get another node. Let's call it cursor. It's starting from the current first node corresponding to a, right? So you can see this is first node. So you can make a correspondence, right? So the last node corresponds to b, and the cursor corresponds to a in this line, and then we move a and b simultaneously to the end. Once a arrives at the end of the linked list, b will at the correct position, right? So basically, it's another while loop. While cursor next is not now. And what we are going to do is last node equals last node next, and the cursor equals cursor next, right? So after we exit this while loop, cursor next will be now. In other words, cursor is the last node, right? So in this case, we get the corresponding b and a's. So actually they are the first node and the last node. So corresponding to a and b here, right? This position and this position. So now we just need to switch their values. So first node value, last node value. So it's going to be last node value and first node value. That's it. So now we just need to return the head of the linked list after modification. So this forms another solution format. So this solution format is still one pass, but we do not use a lot of space to store all the irrelevant information in some sense. So before we make any comments, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I would say for that's the second solution format for this problem. So now let me give a quick summary. In this video, so we shared two solution formats. So the first solution format is basically for the purpose of digest. So we used one pass, however we used the space treat for speed. This space can be improved using the second method. So basically the second method is essentially a two-pointer method. So we first find the case element from the beginning, and then we put a pointer here, and then put a pointer at the beginning, and then we move the two pointer, and once the a pointer arrived at the end of the linked list, the other pointer will point to the correct position. In other words, the case node counting from the back, and then we do the switch of values, and then finally we return the head. So with that done, that's about it for this video. Thank you.